This is our final project for QTM Lab. This group consists of Keshav, Akshay, Ayush, and Joseph. The introduction to this project, we're looking at various drug substances and how they affect neurological pathways in different ways. Understand this is important because substances can affect suicidal ideation and hospitalization. And so this is important in providing care accurately and well. And so using the substance data set, we're looking at how different substances affect the occurrence of suicidal thought in the past 30 days and hospitalization. Further, we're also looking at the relationship between age and the amount of alcohol that you consume in drinks per day. And we can provide relevant resources for alcohol consumption that are specific to different ages. So the first research question is there a relationship between substance use and occurrence of serious suicidal thought in the last 30 days? The rationale behind this is what we mentioned before. We're trying to look at this relationship between substance and having relationships to suicidal behavior. And by analyzing the substance use data set, we can identify differences between specific substances and the occurrence of suicidal thoughts. The null hypothesis is that there is no significant association between the occurrence of suicidal thoughts in the last 30 days and the use of heroin, cocaine, or alcohol. And the alternate hypothesis is that there is a statistically significant association between the occurrence of suicidal thoughts in the last 30 days and the use of heroin, cocaine, and alcohol.
So the second research question looks at hospitalizations across the various drug groups, which include alcohol, heroin, cocaine. So the rationale is that each drug has different levels of severity, and understanding how each drug impacts these rates of hospitalization can help inform care providers and public health professionals on intervention and prevention strategies and techniques. So identifying which drugs have higher rates of hospitalization is critical as well to distribute limited resources. The null for this question is that there's no significant difference in hospitalization across the three drugs, and the alternate is that at least one of the drugs has a different rate of hospitalization.
The last research question we had looks at the correlation between a numerical response and a numerical explanatory variable. The question is there a statistically significant correlation between age and average number of drinks consumed per day in the past 30 days? So the rationale basically has to do with the fact that tolerance to alcohol decreases with age, and heavy drinking can also exacerbate health problems that occur with age. So if older people are drinking more alcohol, it's going to be more dangerous to them. So we want to see if there's a correlation between increasing age and the number of drinks that a person is consuming per day. The null hypothesis is that there is no correlation between age and the average number of drinks consumed per day in the past 30 days. And the alternative hypothesis is that there is a correlation between age and the average number of drinks consumed in the past 30 days.
Moving on, we'll be looking at the variables used for each research question. So for research question 1, we're looking at suicidal thoughts and substance. Suicidal thoughts is the categorical response variable. Substance is the categorical explanatory variable. Suicidal thoughts is whether or not the patient had serious thoughts of suicide in the last 30 days, and its levels are either yes or no. Substance has levels of alcohol, cocaine, and heroin. So for research question 2, we looked at the variables substance and hospitalizations. Substance is the categorical explanatory variable. Hospitalizations is the numerical response variable. Substance is basically the primary substance of use with 3 levels again, cocaine, alcohol, and heroin. And hospitalizations is the lifetime number of hospitalizations for medical problems. For research question 3, we looked at age and average drinks, age being the numerical response variable, average drinks being the numerical explanatory variable. Age is just the age of each patient in years, and average drinks is the number of drinks consumed by a patient per day in the past 30 days. So for recoding procedures, there were periods in the code, so we changed it to NA to allow for R to process the data. For question 1, there was no recoding necessary though, because we were using a chi-square test. For question 2, hospitalizations data was recoded as numeric to ensure that R could conduct statistical analysis. And same goes with question 3. average drinks and age were seen as categorical variables in R, so they were recoded to numerical variables. So a linear regression test can be conducted since it requires two numerical variables.
Okay, now moving on to which statistical tests are used for each of the research questions. So starting off, question 1 uses chi-square test, question 2 uses analysis of variance, and question 3 uses correlation and linear regression.
All right, so we're now looking at the result of research question 1. And first up is this figure on the right. It's the relationship between substance used, and the occurrence of suicidal thoughts. And so we can see for each of the substances, there is a certain amount of the proportion of those who say yes, that they have suicidal thought in the last 30 days after using the substance, and those that are no. And so the chi-square tests indicate that there is an association between the use of substances and having suicidal thoughts within the last 30 days because the p-value is less than 0.05. So the null hypothesis that there isn't a correlation is rejected, and the alternate hypothesis, which says that there is an association, is what we look at. And so this right here is a table. As you can see, under suicidal thoughts, yes column, 66.5% of those who use alcohol had those thoughts, 80.8 for cocaine, and 69.4 for heroin. And this is different than those who said no. And it's physically, you can see the numbers are different, and also statistically speaking, they are different as well.
Okay, so moving on to research question 2, we conducted an ANOVA test, and that provided a p-value of 0.00287, which is less than the alpha of 0.05, which is sufficient evidence to reject the null hypothesis, indicating that at least one group has a hospitalization rate that is different from the other drug groups. A Tukey test was also conducted, which demonstrated significant differences in the mean hospitalizations between cocaine and alcohol and heroin and alcohol. There was a negative difference between both groups, which indicates that there was a significantly higher rate of hospitalization due to alcohol than due to heroin and cocaine. So this plot right here demonstrates the relationship between substance and hospitalizations. The box plot helps us identify like how each variable is distributed. And here is the ANOVA output. For the test, looking at the degrees of freedom, sum of squares and mean squares, we can see how they all arise from the data set. The F statistic of 5.923 provides a p-value of 0.00287, as discussed before, which is significant and shows that there is at least one group that has a different rate of hospitalization compared to the others. And here's the Tukey test, which is a pairwise comparison for the difference in means. And so on the left, we can see how each drug group was compared: cocaine versus alcohol, heroin versus alcohol, heroin versus cocaine. And looking at the far right column, we can see the p-value is significant for the first two, but not significant for the final one, which is the difference between heroin and cocaine. Yeah.
So then lastly, I'll talk about research question 3. So for research question 3, we did 2 separate tests. The first test was a correlation test with the hypotheses mentioned above. So the p-value for the correlation test was 8.285 times 10 to the negative 6, incredibly small p-value. So at a 0.05% significance level, we reject the null hypothesis and conclude that there is a correlation between age and the average number of drinks in the past 30 days. The 95% for the correlation coefficient, confidence interval for the correlation coefficient does not include 0. So the confidence interval also agrees in this sense. And lastly, the estimated correlation was 0.208, signifying that there was a weak positive correlation. Next, we went ahead and created a line of best fit using a linear regression model. And then we plotted that line of best fit onto the scatter plot. You can see that there's a lot of variability in the plot, but that line of best fit does show some kind of positive correlation. So the question now, using the linear regression test, is to figure out whether or not that correlation is statistically significant. So the null hypothesis and alternate hypothesis for this test are slightly different. Instead of dealing just with correlation, they now deal with slope. So the null hypothesis is that the slope is equal to 0, indicating that there is no correlation between the explanatory and the response variable. And the alternative hypothesis is that the slope is not equal to 0, indicating that there is a correlation. So here we can see the summary of the data. We can mostly ignore the confidence interval and p-value for the intercept, but what's important to us, given our alternative and null hypothesis, is the confidence interval and p-value for the slope. So we can see that the line of best fit for the data is negative 1.4161 plus 0.54x, indicating that for every increase of 1 in age, we're seeing an increase of 0.54 average numbers of drinks per day. So the p-value of the slope is very low, again, 8.285 times 10 to the negative 6, which is smaller than our alpha value, so we reject the null and conclude that the slope of the line is different from 0 statistically significantly. And lastly, the r-squared value is 0.043, which is small, but all that means is that there's high variability in our data set. So there is a statistically significant positive correlation. However, the data set has high variability, and not all of that variability is explained by our regression model. The last thing to consider is residuals, which is basically a way of testing how well our linear regression model worked. The mean of the residuals was negative 0.000042, and standard deviation was 1.00. Given the standardized residual model, we have residuals that are centered around 0 with a standard deviation of 1, which proves normally distributed residuals, and with the mean of 0, which indicates that a majority of the data is explained, or a majority of the data is close to the line of regression that was created. The histogram of the residuals is presented below. It's approximately normal, centered at 0, like I said before. There is still a slight right skew, but it's not enough to mess with the validity of our final results.
Finally, it's our discussion. So for research question 1, our test showed that there was a correlation between using substances and the presence of suicidal thoughts. The p-value for this chi-squared test was under 0.05, which means that we rejected the null hypothesis and conclude that there is no correlation. Because we rejected the null, there is a possibility that we committed a type 1 error. These results are concerning, given the fact that alcohol is a very commonly used substance around the world and can result in high levels of suicidal thoughts. There was no relation between these results of the chi-square test and the other research questions being tested. For research question 2, it was important to find association between substance use and hospitalizations because it can help craft intervention strategies to better understand how resources can be maximized to prevent further hospitalizations. By understanding how drugs impact hospitalizations, public health officials can create policy proposals to allocate resources regarding the safe consumption of drugs to prevent hospital admissions. And often, hospitals are faced with an influx of patients. And by understanding what drugs lead to higher rates of hospitalization, these healthcare officials can plan for emergencies to avoid having a shortage of resources. For research question 3, when we use correlation and linear regression, for both tests, the null hypothesis is rejected and the correlations estimated are positive. This indicates that as age increases, the number of drinks per day also increases, which is dangerous given research about old age increasing risk with drinking-related behaviors. There is a possibility that we committed a type 1 error since we rejected the null hypothesis as well. And here's our works cited.